And the bottom line for me is that the food systems have to have culturally appropriate foods available and affordable to the range of cultures that live in our communities now. That if there's people who are lactose intolerant or gluten intolerant, we need to figure out ways to find them foods that can be locally grown that fit their cultural and nutritional needs. So that means democratizing the food system design process. And this is where we need to learn from the collaborative design processes the landscape architects and architects have used in design charrettes for decades. I mean, we have to get smart about how we make design inclusive rather than exclusive. Like, you know, it's just not going to be the kind of scenario where Frank Lloyd Wright of food systems pops up and designs great food systems for the country. It's going to be all of us working together. And there's 3 strategies that I can think of for coming up with some novel designs for our food systems, in addition to taking a lot of hallucinogens and seeing what appears before your eyes. One is using the design principle of biomimicry. In the session that I had with students today, someone brought up Jeanette Banyas's wonderful book on biomimicry, and we found that one biological principle of boundary layers, that plants have all these weird fuzzy hairs and things that keep the sun from hitting their photosynthetic tissue by having this layer out about 1/4 of an inch to 1/2 an inch from the plant skin, the epidermis, can be mimicked in buildings. And we're seeing that kind of strategy even being used by the architects in the School of Architecture at our university, where they have living green walls on trellises about 1.5 foot out from the real walls of the building, and they're actually condensing, getting the condensation off the windows and funneling that down without ever irrigating the vines that are climbing up 4 stories high, passively rather than having to irrigate those plants. They're just growing with the condensation that accumulates in the building itself. So these boundary layers reduce heat loads on walls, keep the air fresher and greener, and they're a biological principle that thousands of plants use. Why aren't we using them? Now go away again. I've told you about that. Let's see. Okay, whoops, so I'm going the other direction. That happened quick. Okay, the next thing is eco-mimicry, and that's looking at the structure of natural ecosystems in our region and how the structure of the vegetation can tell us something about the clusters of plants that we should grow together in guilds. Plant guilds is a concept that both ecologists use and permaculture designers use. And so in the desert where I live, virtually nothing germinates out in the open. All the wildflowers and cacti germinate under these nurse plants, just like in the tropics. Coffee grows under Madre Cacao, the mother of chocolate tree. Well, in the desert, all of our germination begins in what we call dark gaps that are like the light gaps that you have here in the temperate rainforests of the Cascades, where your plants need light, our plants need darkness and moisture and high organic matter that they get from these nurse plants, and that's where we get all the germination. So we're designing multiple strata food systems, and I have about 2 acres of this already planted at my house, where we're combining nitrogen-fixing vines with overstory plants that provide shade, with other ones that are pumping nutrients and water up from lower elevations, and other things that are adding to the soil fertility in a cluster. So we don't think of the desert as being a multiple strata system like a rainforest, but it is. It's just shorter, you know. I mean, some of you guys are really effective and you're short. Well, that's how the desert ecosystems are too. We're just short little guys. And then the third concept is sort of a cultural mimicry, a cultural emulation to generate the multiple uses for the same plants that are growing in a shared space. And I won't go in as much detail as this, but we can take concepts from the indigenous cultures of each region on how to live there and how to utilize plants and emulate that. We can't be Indian wannabes, but we can honor their knowledge and their thought process and learn to apply it to the challenges that we're facing today, hopefully with respect and honoring their contributions to our food systems. So here's just an example. There's a lot of work going on in cities like Tucson and Phoenix and Los Angeles and Las Vegas about how we bring urban farms back into places that look initially like they're light limited because there's all these damn 5 to 10 story buildings around. So how do you design a food system that's sort of vertically stratified that can take being in shade part of the day and full sun in the other part of the day? Well, palm trees figured this out a long time ago. Date palms as well as the wild Washingtonia palms that you even see up the coast into Oregon. And so looking at the structure of those vertically integrated natural habitats can give us some insights on how to design food systems for these skyscraper-ridden metro areas. And there's rapid growth of urban farms all over the country, of course. But the key thing, I think, is that it's going to take a whole different mix of people working together, scientists and artists together, dirt farmers and physicists working together, climatologists and chefs. And the most interesting project I know of like this is called the Window Farms Project, which reminds me a little bit of the Living Walls I saw with Chuck at, what's the name of the restaurant? Singer Hill Cafe today. It's a little bit like that, except they're using completely recycled materials and having these window farms run up the stairway corridors in 15 to 20 story buildings. Britt O'Reilly got a Design Institute degree a few years ago, and she got real excited by the idea of design labs and collaborative design, and got together with a few friends, formed a new nonprofit, said, why don't we use recycled plastic water bottles and cut little wedges in those and put little Dixie cups in them and plop mint plants and basil plants in those, and then have water trickle through whole corridors of these that are linked together so that a nutrient solution trickles down through these, and have solar run pumps pump the water to the top or the nutrient solution back down. Now she has design teams that are working on the best, most cost-efficient nutrient slurries to pump through these systems. Other people working on the filtering systems so that it doesn't get clogged. Others doing experiments to see which herbs, salad greens, fruits and vegetables are adapted to growing in such little space. It's basically a glorified hydroponic system, but some of these are 10 stories tall. And they're using space that's never been used for food production before. So 17,000 people were using this by last September. She was on Oprah Winfrey and Martha Stewart in the month after that, so it's probably well over 50,000 people trying these out. Whole schools are doing it. 1,200 designers are helping her refine this process. And this is what some of them look like. This is the early stages. The design innovations in this system are growing exponentially because 1,200 people to 1,500 people are having input on it every week. Every week now. It's all a cyber network of food system designers. So it's sort of this amazing thing that rather than emphasizing the individual hero as designer like a Frank Lloyd Wright or a Thomas Jefferson, we're saying, let's get us all involved, and we have completely different skills. I'm a soil nutrient geek, and I can help you with the nutrient slurry, but don't talk to me about the aesthetic aspects. Talk to my wife, who's an artist.